One thing I want to clarify, and I'm so glad Sherry reminded me, when we talked about prime numbers yesterday, I gave you some examples of different prime numbers like 2 and 5 and 7 and 11, okay? And I also said 1, okay? I was incorrect because the exact definition of prime number says any positive integer that has exactly 2 factors. Any integer that's positive and has exactly 2 factors. Well, 2 will break down into 2 and 1, 2 times 1. So it has 2 factors. This is 7 times 1. It has 2 factors. This is 11 times 1. That's 2 factors that make 11. And again here. But according to the definition, 1 is only 1 times 1. Well, since 1 is the same, it only has 1 factor, which makes this not a prime. So the number 1 is not a prime number, which I either forgot a long time ago or never knew. So I want you all to have that information. Yesterday I told you 1 was a prime. It is not a prime. It's not a prime number by the definition of prime numbers. Okay, everybody?
Okay.
Yeah.
If any of you, I have, what does that go to 100, that chart? Okay, I have a chart that if you want it, it gives all the prime numbers 1 to 100. They're highlighted for you. And if any of you want that, send me a text and I will email that to you. Okay, can I see it, Brandy?
Yeah.
It looks like this, if it will help you. Okay. I told her
that.
Okay, that 1 was a prime, so she highlighted it, and then I told her it wasn't, so she X'd it out. But it's like this. These were grayed out, you know, the prime numbers. So I have this chart if you want it. Okay, we're in the packet number 1. We're not going to go to the packet number 2 until tomorrow. We're in this probability here, this packet, and I would like to go to page 4. Now, I haven't glanced at it this morning, but yesterday I decided I wanted to go to page 4. Yes. Okay, now this doesn't ask for the outcomes, but there is one, I think it's page 5 when it asks, no. Where's that one? There it is, 6, page 6. We'll go there in just a minute. Nope, let's go to 6 now. You guys know me. Okay, this is page 6. Sorry, I'm changing again. That's not the one. Now, page 8. My bad, guys. So sorry. We'll get started here. It says up at the top, it says a pair of dice is rolled. Now, some of them say a die is rolled. That means just one of them. A pair of dice means 2. Okay, and they're going to be rolled. You roll them out at the same time. Okay, and we're going to talk about all the outcomes. Some of the students were asking yesterday and having a little bit of trouble on this. So the first question says, find all the possible outcomes if I roll 2 dice at the same time. I'm a visual person. So here's one of them. Here's another one. We're going to put them both in our hand and roll them at the same time. Now these are, you guys know what dice are, I hope. And then this one might have 2 on this side and 1 on this side. That's dice. Okay, and you know that there are 6 sides to one of these. They call it a die if it's just one, dice if it's 2 or more. Okay, so we've got 1 through 6 on this one, and the numbers 1 through 6 on this one. They want all the possible outcomes, or if you threw those dice out at the same time, what all things could possibly happen. Okay, and so what we're going to do is we're going to say on the first die and the second one, what will happen on there. Okay, now we could get a 1 here and a 1 on the second one. Are you guys okay with that? We could also, when we threw that dice, just get 1 and a 2 on the second one, or we could get a 1 on the first one and a 3, or a 1 and a 4, or a 1 and a 5, or a 1 and a 6. We can't get a 1 and a 7 because there's not a 7 on here. That's if the first one came up 1. What if the first one came up a 2? If it came up a 2, the second one could come up a 1, or it could come up a 2, or it could come up a 3, a 4, a 5, and a 6. Do y'all see? Do you see where I'm going with this? Y'all in remote, are you hearing me? Do you understand what I'm doing?
Yeah.
Yes.
Then I'm going to have a chart where the first one came up a 3. It could come up 3 and a 1, 2, 3, 4, 5, or 6, with the first one being a 3. And so you can see our pattern. We will also have one of these for the 4s. One of these if the first one is a 5. And one of these if the first one is a 6. It'd be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so how many possible outcomes are there to roll 2 dice? 36. There's 36 total outcomes. Now, if you will write those out on this page 8, in this packet, then when they ask you the questions, you can go to your list and find what you need. Okay, like the next question after you list all your outcomes says, find the probability of showing an even number on both of the dice. Okay, the probability means we need to know the total, but we also need to find out how many places there is an even number on both of the dice. So we go through here. Is 1 an even number?
No.
It's not an even
No.
number. You have to have an even number on both dice. So none of the 1s are going to work. 2 is an even number, but 1 is not. So that's not going to work. But here's 1. This is where both of them are even. That's not even, but they're both even here, and they're both even here. So far, so good, right? Are y'all with me?
Yes.
Okay. Now, 3 isn't an even number, so none of these could fit this question. 4 is an even number, but 1 is not. 4, 2 is 1. 4, 4 is 1, and 4, 6. That's where both of them are even. Is 5 an even number? No. So none of those work, but 6 is. 6, 1 doesn't work, but 6, 2 works. 6, 4 works, and 6, 6 works. Are you guys with me? Do you understand?
Yes.
Okay, so if you have these things written out, it's easy to go through and pick out how many times both of the dice would come up even numbers. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there's 9 times that would come up out of
36.
36, because that's 36 total outcomes. And then you would simplify this to 1/4. So the probability that, throw in the dice, that both of them would come up to be an even number. And you're going to use these outcomes every single time on that page. The next one says the probability of showing an odd number on the second die. So all we're going to do is look at the second one and count all the odd numbers. Okay? Is this odd? Yes. Odd, odd. Only on the second number is what they're asking. So here's 1, here's 1, here's 1. Here's 1, here's 1, here's 1. We can see a pattern, right? There's 3 there, 3 there, 3 there. There's going to be 3 here, 3 here, and 3 here, right? So how many is that?
18.
18.
9.
So I have 18 out of
36.
36, which will simplify to
1/2.
1/2. You're wide awake, Josh, today, aren't you?
Yeah.
It's a good thing. You sound like you feel well. I'm glad. So do you guys get this one, this page?
I do.
Yeah.
We're good? How about in here? You guys okay? I'm going to go backwards now to that page. I think it's page 4. Don't let me. Yes, I'm going to go back to page 4 now that we understand about the outcomes. Okay? Page 4 says we're going to toss 2 coins at the same time. Not dice now, but coins. And everybody knows that there are 2 sides to these coins, a heads and a tails. I don't think there's anybody that doesn't know that part. So we're going to find out, it says, find the probability of showing a head on the first and a tail on the second. Remember and or? Let's put some reminders up. If we see and, what are we going to do?
Multiply.
Multiply. If we see or, we're going to add. And we'll show you how that works. So we know that this has a heads and a tails, and this one has a heads and a tails, of course. And before we answer the first one, how about, do you guys know where we are? It's on it says coin worksheet. Coin worksheet up at the top. I don't think it has, yeah, it doesn't have anything. It says find the probability of showing a head on the first and tail on the second. Okay. So let's find all the things that could happen if we flip these coins. So here's the first coin, and here's the second coin. Okay, so if we flip them together, what all things could happen? There could be a heads on the first one and a tail on the second one. Or there could be a tail on the first one and a head on the second one. Or there could be a head on both of them. Or there could be a tail on both of them. And that's all the possible things that could happen if you toss 2 coins at the same time. All right, 4 possibilities. And now it wants to know the probability of a head first. And then it says, and the probability of a tail on the second one. Okay, now there's 2 ways you can do this. You can look in all of our outcomes and find this, where heads is on the first and tails is on the second one. So how many times did that happen in there?
1.
1 time right here, where heads is on the first coin, tails is on the second. It didn't happen again. So it's 1 chance out of how many outcomes? 4. Okay, now where I was talking about the and, I need you to understand this too. Either way is fine. So what's the probability of getting heads on the first coin? Just heads on the first coin. What's the probability? 2
2.
out of 4, right? Or that reduces down to 1/2. And we said and is multiply, right? What's the probability of getting tails on the second coin?
2.
2 out of 4, which is 1/2 again, right?
Yes.
When we work it that way, what do we get? 1 times 1 is 2 times 2 is
4.
4. So either way, whichever is okay with you, you're still going to get the same answer. Are we okay? Okay. Any questions on the remote side?
No,
No,
seems kind of
Okay.
easy.
Some of these are worded strangely. Right after that one, find the probability of not showing heads or tails on both coins. Okay, if you break it way down, you can think about it normally, but it's kind of hard with the not in there. But you can also say, what's the probability of not heads or tails, okay? And then it says or, so that's going to be a plus. And then the probability of not heads or tails when you do the second one. The nots, you kind of have to think about it when it says not something. So let's find out the probability in here that there's no heads or tails. All of them have heads or tails, right? So the not is going to be 0 chances out of 4, right? Yeah. Because all of them are heads or tails. So the not heads or tails is 0. Or what about the probability on the second one that it wouldn't be heads or tails? Right?
Yep.
Now 0 on the top of a fraction is perfectly legal. That means this is 0. You cannot, listen to this, you can never have 0 on the bottom of a fraction. It's like against the rules. It doesn't exist. It's illegal. Can't have 0 on the bottom. 0 on the top is fine. That means this whole thing is 0. This whole thing is 0. And so the probability is 0 that those coins would not come up at heads or tails. They're all heads or tails. Silly people. Okay. Okay, then the next one, let's just go ahead to the next one. It says find the probability of showing either a head or tail on the second coin. So I need the probability of a head or tail. And this is just on the second coin is what they're talking about right now. Okay, what's the probability? Look down the second coin. What's the probability of them having a head or a tail? That means you're going to add them all. 4. There's 4 heads or tails in the second coin. Out of how many outcomes? 4. So the probability is 1 whole or 100%. Okay, because all of them are true. So you can have all the in-between fractions, or you can have a 0 probability where it never happens. And you can have a 1 or 100% probability where it happens all the time. Yeah. Okay. And then I think I saw something maybe on 6. Now on the days of the week when they talk about a weekend, I talk about Friday, Saturday, and Sunday as a weekend, but they're talking about Saturday and Sunday being the weekend. That's just to let you guys know that. We talked about prime numbers and even numbers. Multiples. Let's make sure everybody understands multiples. I'm on page 7. It says fair die worksheet. So we're working up here. It says, when it says die, that's just 1. So now they only have 1 on this page that they're going to roll. Okay, and this is page 7 if you're numbering them. Now, I think you can find the probability, but sometimes people get mixed up on what multiples are. So let's talk about multiples for just a minute. And then the bottom one talks about a divisor. So let's explain what multiples are. A multiple is when we multiply. Is when we multiply. A multiply. Okay. A multiple is when we multiply. Okay, so if I want multiples of 3, then I will have 3. That's the 3 times 1. What about if I take 3 times 2? It would be 6. If I took 3 times, or 3 times 3, it would be 9. Times 4 is 12. And so on. All of these are multiples of 3. It's when you take 3 times 1, 3 times 2, 3 times 3, 3 times 4. Okay? Multiples of 2. How about multiples of 2? Multiples of 2. We start out with 2. What's this one?
8,
2 times 3. 2
6,
times 4.
8,
2 times 5.
10.
And so on, all the way. These are all multiples of 2. You see how multiples work? Okay, and then down at the bottom, they ask about divisors. Let's get a big one. A divisor of 32. Okay, that means all the numbers that you could possibly divide into 32. It'll divide by 1, won't it? Will it divide by 2? Mm-hmm.
Yes.
Will it divide by 3? No. Will it divide by 4?
Yes.
About 5.
No.
6, 7, 8,
Yes.
9, 10, 11, 12, 13, 14, 15, 16.
Yes.
17, 18, 30, 31, 32. These are all the numbers that would divide evenly into 32, right? These are all divisors of 32. So what about divisors of 24? Tell me. Always starts at 1. Well, 2? Yes.
2,
3?
3,
No, 5, 6, 7, 8,
8,
9, 10, 11,
12,
12, and 24.
24.
Now, one way that'll help you remember, once you start this side, look, I have 3 times 8 is 24, 4 times 6 is 24, 2 times 12, 1 times 24. And that's how I remember what the big ones are, because I did the first ones. If that helps. These are all divisors. That means what will divide into the number. Okay, so when you work this page, you need to know what multiples and divisors are. And then you can do the probability on positive. Just think about it. We talked about cards yesterday. How many of you bought a deck of cards? Anybody? No? Okay, multiples of 10, multiples of 4, or multiples of 5. So you're going to find the probability twice and add. Black card, that's a deck of cards. This is a deck of cards. This is a bag of different colored balls. Okay, now odds. This is where I kept trying to help Sandra, and I kept getting it wrong because I remembered incorrectly. But I will be specific on why I got it wrong and how I got it straight in my head. Okay, so I'm on this page. It says probability worksheet, and it talks about 25 students in grade 5. Okay, it's close, next to the end, I think, next to the last one. All right, we're going to look at both of these pages. If you numbered it, it's page 14. And it starts with probability, and we're going to ignore that for a minute. We're going to come down here where it says odds. All right. Now, the main things, I'm not going to write all the words, but it says there are 25 students in this grade 5. Now, it says in this classroom, there are 15 boys. Well, if there's 25 students and 15 boys, there's definitely girls in this class. And then it says, we're going to go in, close our eyes, and pick a student. Okay, so we're going to find probability or odds. Let's go ahead and do the probability first. Okay, the probability of selecting a boy, if I don't look and I just point. What's the probability that I will point at a boy? 15 out of 25, right? And then when we simplify that, we'll come to 5. Out of 5 that I would point to a boy. What's the probability that I would point to a girl? 10 out of 25. I don't see 10 up here. How did you get 10? You're exactly right. If there are 25 total students and 15 of them are boys, 10 of them are going to have to be girls, right? So you have to do a little work here, and then the probability that I pointed a girl is going to be 10 out of 25 or 2 out of 5. Now that's probability, and we're fine with that, right? Now the odds. Sandra, help me, okay? In a minute. Let me make sure I get these right now. Now, oh, I probably needed that. We're going to find the odds They said find the odds in favor of a girl. That says boy. We'll do the girl one. Odds in favor of a girl. Okay? So that means we're going to list the girls first. Okay? So 10, that's in favor of the girls, and odds we write with a colon. Now, when we write the second one, it's not like probability. It's not out of 25. These two numbers have to add to the total. So it says, if this is girls, that's in favor of the girls, I need to write the boys here. This is in favor of the girls. And notice that the 2 in the odds, when you're finding odds, these add up to the total. You don't put it over the total. I'm right here. Okay. And then we reduce or simplify, divide by 5, just like you would a fraction. And so we have 2 to 3. Okay? This is odds. And of course, if it's odds in favor of a boy, they're just going to be switched. So the boy is in favor here. So it would be 3 to 2. Let's look at the last one. Aha, it's asking you the odds against a boy and the odds in favor of a girl, are they the same? Yes, they are. Here's the odds in favor of a girl. Now let's do odds against a boy. Well, if it's against a boy, then it's got to be the girls in favor of the girls. If it's against a boy, then it has to be the girls. Y'all see? So the difference in odds, first of all, is the way we write it with the colon, still simplified. And the other big difference is the two numbers need to add up to the total. You don't have it over the total, but they have to add up to the total in the odds. And I want to go ahead to this last page because it deals with percent. Okay. And it says the odds. So if we're dealing with percent, what represents the total percent? Total percent. 100. So 100 is our total. Now they said, in number 1, it says the possibility of raining today is 40%. So rain would be 40 out of 100. Okay? This is the total. So for it to rain, we've got a 40% chance. So this is not rain. What is the chance that it's not going to rain? Come on, if this is the total. I'm sorry, 60. So now it says in A part, find the odds that it will rain. That it will rain. Well, here's our number that it will rain. They said odds. So we need colon. The in favor goes here. Not the total, but the other that adds up to the total. And when you simplify, you're going to have 2 to 3. So if they turn that around and they said, find the odds that it will not rain today, can you see that our odds are just going to be flipped? Rain or not rain. So this is how you deal when it gives you a percent. The total is going to be 100. And then whatever percent they give you will be here. 40%, 60%. Does that help clear that up? Okay. Let me see here. I think that's pretty much what I was going to do today, is talk about 1 is not a prime number. And I was going to go over things I thought might be confusing. I'm going to answer questions if anybody has some on this packet. And tomorrow we're going to start, it'll be probability again, but we're going to be dealing with permutations, combinations, and a thing called factorial. Now, the good news is I want all of you to have your calculators, because every one of those problems are going to be done on the calculator. I will explain what permutations and combinations are, but we don't have to do anything. We're going to use the calculator to figure those things out. Okay, so the 3 things we're going to deal with tomorrow: permutations, combinations, and factorials. Now, before I stop recording, are there any questions on the worksheets that you had trouble with other than what I went through just now?
I'm good.
Oh, I don't.
Okay. All right, this was a shorter lesson, but I don't want to hurry and push you into the next lesson until you've had time to work on these. Now, I would like for you to have all this worksheet done by tomorrow so that we can jump into packet 2. Packet 2 is not quite so long. And be sure you have your calculator with you so that I can show you exactly where to work the problems from tomorrow. We're going to use calculators almost the entire time in packet number 2.
Okay.
And now again, some of the students have asked, when I'm through with the lesson, can they stay on and just work while we're still on a Zoom? I will leave it up until 12:30, as long as you guys want to stay on and work and then be able to ask questions if you have them. So I have no problem with that. I've had students stay on with me. So I am through for today as far as the instruction. I'm going to stop the recording, and then you all are